everyone. Today we're going to talk about concept probability. So when we use probability, there are a few terms we use. One is experiment. So experiment is any process in which the result cannot be predicted in advance is an experiment. So within experiment, if number of times we are doing this, repeating the same process is called trial. And every trial, we are getting a result. That result is outcome. Now there is possibility that every trial we are getting separate outcomes. So we are looking for all the possible outcomes that we can get, that we call sample space. Now in a question, when you get a question, usually you get, okay, what is the probability of getting a 1 when you roll a pair dice? So that asking for that 1 is an event. Now, what is probability? In mathematical terms, probability of an event is number of favorable outcomes over total number of outcomes. For example, what is the probability of getting a 1 when we roll a dice? So this is the sample space of a dice. So how the favorable outcome I can get out of these sample spaces for 1 is 1. And the total number of possible outcomes I can get is 1, 2, 3, 4, 5, 6. So the probability of getting a 1 when we roll a dice is 1 by 6. So what's the difference between probability and odds? So odds of an event is equal to probability of favorable outcomes over probability of unfavorable outcomes. So we are continuing with the same example. So in this case, the favorable outcome of getting a 1 on a dice is 1. Unfavorable outcomes are the rest. 2, 3, 4, 5, 6. So total 5 unfavorable outcomes. So the odds of getting 1 on a dice is 1 over 6 divided by 5 over 6, which is equal to 1 by 5. So now you see the difference between probability and odds of getting 1 on a dice. Now the next concept is probability of get independent, dependent, exclusive, or inclusive events. So let's say if we are finding an effect of one event on the other event in multiple trials. If that's the case, then it becomes a dependent event. For example, in bingo, for first trial, each number has 1 over 99 probability. For the second trial, for the remaining numbers, the probability would be 1 over 98, and so on. So every trial affects the other trial's probability. Now, if it does not affect, then it becomes independent event. For example, in dice, for first throw or a trial, each number has a probability of 1 over 6. If we throw it second time, each number still has probability of 1 over 6, which is no change, and so on. So this is independent event. Now, occurrence of event together in one trial, if they can occur together, then it becomes inclusive event. For example, probability of getting even number or greater than 3. So if we are looking into even, there are 3 out of 6 probability that we can get even number. For greater than 3, there are 3 out of 6 probability that we can get greater than 3. But if you notice over here, there is a probability that you can get even as well as greater than 3 numbers. So which means that this event is inclusive. Exclusive, for example, probability of getting 3 or 6. So probability of getting 3 on a dice is 1 over 6. And probability of getting 6 on dice is 1 over 6. But over here, did you notice one thing? If you're getting 3, there is no probability you can get 6. And if you're getting 6, there is no chance that you can get 3 as well. So this becomes exclusive event. Now, when we are talking about dependent and independent events, usually you get the question to find a probability of event A and event B. So you see in this one, and is common. When we are talking about occurrence of event together or not, inclusive or exclusive events, you will find wording like probability of event A or B or both. So or over here is common. So that tells you that whether you are finding different inclusive or exclusive event or dependent or independent event. Now the formulas. Now if we are finding dependent and independent probabilities, like in this case, you can replace and with multiplication. So probability of A and B is probability of A event multiplied by of probability of B event, whether it's a dependent or independent. Now, if it's an exclusive or inclusive event, for or we are changing it with plus sign. So probability of A plus probability of B. Now in inclusive, we have minus probability of A and B, because when you add probability of A and B, you are adding the events that occur together twice. To minus that occurrence calculation of twice probabilities, we are minusing probability of A and B. Now in an exclusive event, probability of A or B, we are just calculating probability of A and probability of B, because there is no duplication or occurrence that happening together twice at the same time.